All right, so I'm gonna go over the layout for a squared around elbow, as well as a couple of definitions for some words that could possibly be on your test. But we're gonna start here with the squared around elbow. So I've pretty much done all the work here already. Just kind of gonna go over it with you. It's very similar to the oval to round elbow. Find the miters the same way. This is again a 3-piece one. The reason why I'm showing you 3-piece ones is because they are much simpler to lay out than a 4 or 5-piece oval to round and squared around elbow. I'm going to show you a picture of one after this is done, and how it gets even more complicated. But just to start, I did a side elevation of the squared around elbow. It's 4-inch round to 5x5 square. Did the profile of the 4-inch round here, divided into equal spaces, and drew those lines to the miter. And then I did a profile of the 5x5 side down here as well. So 2.5 inches this way, 5 inches, 2.5. I have the seam right here on the round and in the middle on the square side as well. And then you can see I have, instead of zigzag lines, it's just like a squared around in the middle. So this is just a mitered squared around as the middle gore. So the first thing I did was the same as on the oval to round. I did the two ends with parallel line. So this is the 4-inch round side here, pretty simple. And then the rectangular side here. And it goes with my labeling because I have the seam in the middle. I have 2.5 inches here from A to B, and then B to C is 5 inches, C to D is 5 inches, D to E is 5 inches, and then E to A is 2.5 inches. And on the B to C side is the short side, so the height of it is taken from right here. D to E is the high side, and the height of it's taken from there. And then the height of the seam section is right there. So I literally take that section and get the height of it there. So it should be tapering up on this side and down on this side. So when it all comes together, it meets and makes that exact view right there. Hopefully that makes sense. Now when it comes to, well, and we need this too, because when we're laying out the pattern, we need this sloped side here, which is the same as this sloped side right here. But we need that when we're doing our step-offs for the base of the rectangular piece here, or the center gore. You definitely do not want to take the C to D from down here, because obviously that's much longer than this. So anyway, moving on to the pattern. So that's what the pattern is going to look like when it's all done. But to start the pattern, we'll take the true length of the back side here, because we're going to start in the back center. So I took that true length right there, and that's that starting point from here to here, right? So that's where I have the small e. Small e is going to be right in the center of that back side. And then from D to small e is 2.5 inches. So I went 2.5 inches on either side, and it makes this triangle right there. Now, going on either direction, you were just staying from these 2 points. So the first number of marks we're doing is going to be from a single point. And you can see we got 1, 2, 3, 4 points. 1, 2, 3, 4 points from just these corners. So 1, 2, 3, 4, 1, 2, 3, 4, right? From these points, or this point and this point. So it's just a matter of taking the measurement from here. So I have this line here is going to represent 3 and 5. So if I take that length, bring it right down to the baseline here, and mark a point, and then I labeled it 3 and 5. And then I took the profile, the 3 and 5, right there. And then I subtracted it off of this profile, right there, 3 and 5. And then that length there, 3 and 5. So hopefully you can see that. From 3 and 5 there to 3 and 5 there, that hypotenuse becomes the true length. So now I can swing 3, and then from this side I do 5, right? And then the step offs for the top, I got from these lengths here. So 4 to 3, 4 to 5. Right, all the step ups on the top are going to be the same, but I do get them from that where this miter is going to match up with this edge here. So, and it's just that same process repeated over and over again. So then I have the 2 and 6. So that measurement here, 2 and 6. Brought it down to the baseline, made a mark. And then the 1 and 7. I brought down to the baseline, made a mark, and then subtracted the profiles. 2 and 6, I took off this profile, and then 1 and 7, I took off this profile here as well. And now 1 and 7, I'm also going to take off this side. 12 and 8 come off this side. 8 and 9 come off this side, because these three are based off this corner of the pattern. So, and then, so once I could, just match them up. If you label them properly, just match up, and the hypotenuse will end up being the true lengths. So that 2 and 6 matched up with 2 and 6 here. I got my 2 and 6. And the 1 and 7, I did the same way. And then once you get to 7, which is the 1 and 7, that's the halfway point. Then that's where I'm gonna need to make this second triangle here. So I got the first triangle, now I gotta close this triangle in. So when you get all the way down to 7 and all the way down to 1, now we have to start working for the other portion of the pattern. So to get from this E to B here, that's where I take this mitered length, or I can do it from this view as well, from this length here, that slope length. That length there, which is gonna match this length here. And that's where I'm gonna swipe it up from E to B and D to C. They should match. And then I need to go from the 1 and 7 down to the CB. So again, I take this length here, the 1 7, that length there, bring it down to the baseline, mark it there, 1 and 7. I've subtracted this profile length off of here already, and then that hypotenuse there, 1 and 7, is this line here now, going down this direction, and from 7 down to C, right? It gets me to B, to C, and then close those triangles in, and then we can work on our next 4 points up here. So, and it's the same thing, taking this length here, bring it down to the baseline, making a mark. I've subtracted this profile off, and that hypotenuse there becomes the new true length. And you just repeat that until you get all the way to number 10 here. And 10's gonna end up being on both sides. Now the number 10 one, we're not using this true length right away. So we're gonna take that number 10 measurement there, bring it down to the baseline, mark the number 10. There's nothing to subtract off of here, so we use the entire length for this last one here. So I'm going to go right from the corner to number 10. And that's where I get this B to 10 length and C to 10. And then coming back down from 10 to small b, 10 to small b, that's where I'm going to take this true length here finally. That length there. And that's going to go from 10 down. And 10 down. And now the small b to C is just right there. Taking that as a true length. And that's the same as the D to E. But it doesn't really matter. We're going from C to small b. So then we can go C to small b and B to small b right there. And that's it. Closes off the pattern. So you should end up having 4 triangles. 1, 2, 3, and then these 2 make the 4th one, right? Because each one of these is half of it. Yeah, that's basically it. Not too bad. I find the squared around ones easier than the oval arounds for sure. Hopefully, I kind of did that quickly, but hopefully that makes sense. I spent way more time on the oval around, so the process is very similar. This one here just takes less steps. Before I end this video, though, I wanted to point out a couple other things, some terminology that are going to be applicable to this next test, and something I've mentioned briefly before, but I just want to remind you. It's kind of a review. This is a flat on back T. So quite often they'll want the seam at the shortest point on the T. Typically I don't do this because the shortest point is going to be on the center of the larger pipe here, which would be right here. I just tend to make my seam right on the center of the T itself, right? If they insist on there being the seam at the shortest point, it doesn't line up with the 12 divisions that we do on the main pipe here. So you would have to add an extra line in there. And that extra line is called an auxiliary line. So that's really important. So this is something you might see on the interprovincial exam. So anytime you have to add an extra line in there to complete your layout, it's called an auxiliary line. The other one I wanted to show you was a multi-piece squared around, like more than 3 pieces. So this one here is a squared around elbow that's 4 pieces. So on a 3-piece one, it's really easy because you have the 2 end gores, which are parallel line, and then you're just triangulating that center gore. And you're using the profiles off of your parallel line gores to help lay out the middle one. When you have multiple pieces in the middle, you have to do what's called a sector, and that's a modified profile, because like you can see, as this thing is shrinking down, it's not, you know, from when it's the regular square around, it's round up here and square down here. Like at this miter line, it's going to be not square or round. It's going to be kind of a combination of the both. So you have to do a modified profile here, and it's called a sector. So on a 4-piece like this, you would only need 1 sector to lay it out because you have the regular profile here to do this end of it. You have this profile to do this end of this piece, but to actually make this middle gore properly, to lay this out properly, you'd have to make this sector or special profile. If it was a 5-piece, you'd need 2 sectors and so on. But for a 4-piece, you just need the 1. Hopefully that makes sense. If you guys have any questions, just call or email, just like normal.